Today we're going to be learning about multiple representations of data, starting with an equation, then taking it to a table, and then creating a graph off the data. We're going to start on page 74 in your spiral. The first thing you're going to need is the scenario, and this is going to be step 1. So I'm just going to put a 1 at the top and 4-corner glue the scenario all the way at the top of our spiral. Now, be sure to do cubes while I read the problem aloud. Miss Jackson translates books for a living. She decides to change her fees to keep up with the cost of living. She will charge an initial fee of $325 to manage a project and $25 per page of translated text. Go ahead and do cubes. You should have circled two important pieces of information. The first one is that she's going to charge an initial fee of $325 to manage a project and $25 per page of translated text. What this means is that she's going to charge $325 every single time for a project, and then on top of that, she's going to charge $25 per page. We don't know how many pages yet, but it's going to be $25 per page. So go ahead and look at the equations below and see if you can choose the correct equation that goes with the problem. I'll give you 10 seconds. Okay, so right off the bat, we can cancel out two of these answer choices. Since she's charging an initial fee of $325 and $25 per page, it's going to be this amount plus this amount. So right off the bat, I can cross off B and I can cross off D because they have subtraction. Now, from A and C, I know that the correct answer has to be C, and that's because X stands for the number of pages, which we don't know. So that's the X, and that initial fee that only gets charged one time. Okay, so off of our equation, now we're going to the next step, which is to create a table. We're actually going to do this on the next page, so flip over your spiral. And this is going to be step 2. And go ahead and 4-corner glue that table onto your spiral. So think about what you know about the values in the table. We have number of pages on the left and total cost of the project on the right. Which one is the X and which one is the Y? The X is always on the left. It's kind of like the order of the alphabet. So X is always on the left, and then this side is going to be the Y. So X's and Y's. And just as a refresher, our equation, let's write it over here, is y equals 25x plus 325. It was 25 pages, $25 per page, we don't know how many pages, plus that original fee that gets charged every single time. So if you think about it, what are we going to need to do with these x's to figure out the missing values of y? And what are we going to need to do with these y values to figure out the missing x values? What is that called when we take a number and we put it in for something else like a letter, variable. Substitution, very good. So we're going to do our substitution work down here, and you want to make sure to show every step. So for this first one, I'm going to call it problem A. Every single time, we're going to start with the equation. So I'm going to copy this equation right down here. The equation does not change. Y equals 25x plus 325. If you look at the first row in our table, I have the number 1 under the x column. So 1 is an x, so I'm going to substitute the number 1 for the variable x. Be sure to put the parentheses so it doesn't look like 251. And that's substitution right there, where I rewrite the equation, but instead of x, I put in my 1. And now all we have to do is solve. What is 25 times 1? 25, very nice. So last but not least, our answer is $350. Very good. And I can put a box around it because I'm done and put that value up here in my table. Okay, go ahead and grab your grading pen. We're going to make a line going down the page here so we can organize our work. And now let's do the next value in the table. Next value is 2. Is it an x or a y? It's an x. So again, we're going to substitute it in for x just like we did for part A. Part B, again, remember every single time you start with the what? The equation, because the equation doesn't change. Y equals 25x plus 325. And again, we're substituting 2 for x or y? For x, because it's under the x, so it's an x value. Parentheses 2. I'll give you about 10 seconds to finish this problem. Okay, we should have gotten y equals 25 times 2 is 50. Bring down my plus 325, which means that our final answer has to be $375. And you can put that in your table. Okay, so far so good. We're substituting the values in the table so that we can calculate the missing values. Grab your grading pen and we'll make a line straight across to organize our work. And on to the next. Now, the next row, you'll notice we don't have the X. We have $500, but is that the X or the Y? That is in the Y column. So this time, we're not going to substitute 500 for X. We're going to substitute 500 for Y. Here we go. This is part C. Again, what do we start with every single time? This equation. Every single time you start with the same equation. So write that down. And as I mentioned before, 500 is not an X. 500 is the Y value, so I'm going to substitute it for Y. And as you can see, now I'm ready to solve for x, which is what I'm missing in my table. I'm missing the x value, and that's what I'm prepared to solve for. Now we're just solving an equation. What's the first step we do when we solve equations? Every single time, very nice. Circle and line. Circle the variable and its coefficient and draw a line down the middle. If I put my finger right here, what do we need to get rid of first? That 325. So go ahead and subtract 325 from both sides. I got 175 equals 25x. These 325s cancel, which is what I wanted. And the last step is to divide by 25 on both sides. Go ahead and do that off to the side. 175 divided by 25. Should be exactly 7 times. And my 25s cancel, which means that my answer is 7. X equals 7. So when the total cost of the project was $500, that means that we translated 7 pages. Okay, and now let's do the next one. For part D, again, we're given $550. Look at the table. Is that the X value or the Y value? Very good. This is the Y value because it's under the Y column, which means what variable are we going to substitute for? X or Y? Y, because it's under the Y. Okay. First thing we write down, though, every single time is the equation. The equation does not change. Go ahead and substitute the $550 in for Y. And now you're ready to solve for X, which is our missing variable, and I'll give you about 30 seconds. Okay, the first thing you should have done is circle and line on both sides. If I put my finger here, I know I have to take away the 325 from both sides. $550 minus 325 gives me 225. 25x remains on this side. Cancel these, which is what I wanted. And the last step was to divide by 25 on both sides. And your final answer should be 9. 9 equals x. Put a box around it and we're good to go. So if the total cost of the project is $550, then that means that there were 9 pages that were translated. This goes in my table. And last but not least, section E. Go ahead and grab your grading pen one last time. Organize our work here. This is section E. And I want you to do this one completely on your own. I'll give you about a minute and then I'll go over it. Okay, I hope you remember to start with the equation every single time. And in this problem, in this row in the table, we were given 10. Is 10 an x or a y? It is an x value because it's under the x column. So I know that I'm going to substitute it for x, which means everything else stays the same except for the x. Now, what do you want to remember to put around your 10? Parentheses, so it doesn't look like 2,510. $25 times 10, I know is 250, which makes my final answer $575. Raise your hand if you got this one correct. Nice, good work. And we can put that in our table. So for 10 pages, the total cost would be the $575 we just calculated. Very nice. Okay, so just a few notes to put off to the side, just so you remember what to do in the future and on your homework. Start with the equation. And then substitute. And be sure that you're substituting for the correct value. If it's on the left, you're substituting it for x. If it's on the y, or if it's on the right, you're substituting it for the y value in the equation. And then you just solve for the missing variable and then add that to your table. Okay, awesome job so far. So far, we have read the problem, we picked the correct equation, we created a table off of the equation by substituting, and there's our work at the bottom. And now for the third part of this whole thing, representations, is to create a graph off of our data. So let's go back onto our previous page. And right underneath that scenario, I'm going to put number 3. I know we're a little out of order today, but that's okay. It's just so we can show all of our work. This is part 3, and we can go ahead and four-corner glue our graph onto our spiral. Now, you may be wondering, but Ms. Munoz, what data, where am I going to get the points? Where am I going to get the ordered pairs that go in this graph? How am I supposed to make a graph? I don't have any ordered pairs. Remember, our ordered pairs are going to come from the table. These are our x values and these are our y values. These right here are our ordered pairs. We've done this before. Think about it. How can we make this table, the values in the table, look like the ordered pairs that we're going to put in our graph? What do we need to add around our table to make them look like ordered pairs? Very good. We need to add parentheses on the outsides and a comma right in the middle to each one, just like this. Okay, and there we have it. There we have our ordered pairs that are going to go in our graph on the other page. Okay, so here we go. I'm just going to do this first one with you, and then I'll give you some time to plot the rest of the points. The first ordered pair is 1, 350. Remember, when you're graphing points, the first thing you need to do is the x-axis, which was 1. So I'm going to go over to 1 and then up to 350. So x-axis first, and then y-axis. So over and then up. So in this case, I go over 1 and I go up to 350 and I put a dot. Just like that. Let me flip it back over so you can see my table. And you have 30 seconds to plot the rest of these points. Ready, set, go. Okay, I'm going to go ahead and plot the points as well very quickly. Next one was 2, 375. So this is over 2, up 375. Next one was 7, 500. Over 7, up 500. 9, 550. 9, up 550. And last, I have 10, 575. If you look at these numbers, 10 would be right on this line. And if you look at the y-axis, we're counting by 25s, which means that last one would be 575. Very nice. Okay, so our graph is complete and we made it off of the values in our table. The last thing we're going to do is we're going to examine a few things and make some notes at the bottom about our graph. So the first thing I want to ask you is this graph going to be continuous or discrete? Ooh, and it's been a while since we talked about those vocabulary words. Continuous versus discrete. If you're not sure what I'm talking about, go ahead and flip in your spiral to page 16 right now. Continuous versus discrete. This is when we learned about two different ways to represent data. A continuous graph, as you can see here, is when the dots are connected, and discrete graph is when the dots are disconnected. And remember, the questions you have to ask yourself are, can you have half of whatever's on the x-axis and whatever's on the y-axis? So let's look at our example. On the x-axis, I have pages translated. Can we have half of a page? Sure. Look at what's on the y-axis. Can you have half of $1? Of course you can. So since we can have half of each one of those, that means that I can connect these dots, so our graph is going to be continuous. And let's write that below. Continuous, because I can have half a page and half $1. So that means the dots are connected. And let's go ahead and do that on our graph right now. Just do your best. If we had 0 pages, then I know that that would mean $0. So I can go ahead and put a dot right there and just do your absolute best to connect these dots and create a straight line. Now it is a line, it is going to keep going, so I'm going to put a arrowhead right here. Okay, now the next question I have for you is, does this graph directly vary? Directly vary, direct variation. Does this graph directly vary? Well, if you remember from the notes we make on our star chart, right here, I can see that direct variation has something to do with this picture. This picture that we draw of this line is supposed to remind us of 2 things. I'll give you 10 seconds to brainstorm. What are the 2 things that this graph is supposed to be showing us? Okay, hopefully you remember direct variation means that our graph goes through the origin, crosses through that 0, 0 point, and is a straight line. Let's take a look at our graph. Does our graph go through the origin? Yes. And is it a straight line? Absolutely. So our graph does directly vary. I'm going to write directly varies because it goes to the origin and is a straight line. Oh, you can't see it, sorry. Okay, and the last thing that's going to go in our notes is that if a graph directly varies, remember, direct variation means the same thing as if a graph has a constant of proportionality. So if we're saying yes to direct variation, we are also saying yes to constant of proportionality. Okay, and now you're ready for your homework.